Hey everybody, it's Mrs. C. I am here doing a video for you on how to find the slope of a line between two given points, or as many given points as they want to give you. As long as it's on the same line, it really doesn't matter. So in the case of this line, I have a line that looks to be going downward. I have point B at negative 15.4. That's this one right over here. And I have point A at 5, negative 3. Now, in the past, we have calculated slope by finding the rise-run relationship. So actually, on a graph, we can count how far up and then how far over one point is to the other, and we can find out what its rise to run is, which ultimately is its slope. But today, I want to go over a couple different methods. Now, there's two methods, and I'll show you. The first one is the slope formula. And the slope formula goes something like this. M is equal to y2 minus y1 over x2 minus x1. Now these are subscripts. I just don't say y subscript 2 minus y subscript 1 because that's a whole lot of talk and not as much action as I like. So y2 minus y1 over x2 minus x1. And it's actually very complicated. It looks very impressive. You can show off with your knowledge of, hey, look at what formula I know. It's really a very straightforward formula to use, though. So in order to calculate the rise-to-run ratio of any given pair of points, you just need to plug them in. And let me explain what we've got here. y2, and if I just change a little color here so you can see, the y2 and the y1 are referring to the two different positions of the y's. For example, let's say that this A here is my original xy pair. So let's say this is my x1 and my y1. And then if I come over here to B, because B comes after A, right? We would then call this the x2, y2. And that 2 is just telling you which point. Was it the first point? Was it the second point? Was it the third point? In this case, I named my points by letters and numbers because you can imagine how confusing it would be if I started using numbers to name points that already have 2 points to name the point given the xy pair. So I'm confused just saying it, so you can imagine how confusing it would be. Now, let me go ahead. I'm going to go over to the next page, and though this is a great idea, I'm thinking it would be nicer, a nice clean page, and in fact, not just a clean page, but let's go completely clean so you can really focus on the formula. So here we go again. I'm just going to make up, there goes my dog, I'm going to make up. Okay, so I'm just on this page. Let me write it for you again. M is equal to, do you remember? y2 minus y1 over x2 minus x1. And I just want to show you one more time using a pair of points. And I can't remember what the original points were. I don't really care. Oh, fine, I'll care. Let me come over here. A was 5, negative 3. 5, negative 3, and B, let's go back to B. B was negative 15.4. B was negative 15.4. Okay, so now here we go back with the which one's 1, which one's 2. Well, let's call A our x1 and our y1, and we'll go with B as the x2, y2. And again, the 2 and the 1 just referring to the first point and the second point. Now all you have to do is just plug them in, and this is just about as easy as it gets if you don't get too confused with all the craziness going on. For example, x1. Here's the x1. Here's x1. So you put a 5 in there. And then let's find somebody else. Here's x2. Here's x2. You put the number in there. And then let's do the y's. Here's y1, here's y1, negative 3, and here's y2, here's y2, number 4. It's like a children's book, isn't it? Now, the hardest part is is looking at it. The hardest part is actually just cleaning it up. What was m equal to? Okay. M, by the way, is the variable we use to represent slope. Don't ask. I'm not even going to go into why. All right, we have a 4 minus a negative 3. Be careful. You see the negative here, and you see the negative here. That's minus a negative. You don't want to lose that. And then if you can read through that, it's a negative 15 minus, and this is just a regular 5 in there. See, this was originally just a positive 5, so it's just goes right there behind there. Now the double signs be positive. The double signs be positive. Yes, they be. So we have a 4 plus a 3. I'm going to come down and do a little funness here. 4 plus 3, yes, I said funness, is 7. And then down the bottom we have a negative 15 minus 5. That's two signs the same. Add, keep the sign, right? Same sign, sum. Negative 20. So our slope, m, is actually equal to a negative, put it off to the side, it makes it look prettier, 7/20. That means I would actually rise a negative 7 and run a positive 20. Come back over here for fun. M is equal to a negative 7/20. Now what is the negative? The negative is telling me my line is going down, downtown. And that's what the negative is telling me. That's all it is telling me, really. The line's going down. So from any point, it doesn't matter if you start up here at B or down here at A, you're going to be going, in this case, let me erase all of it. Hang on a minute. This is just a little bit of craziness going on here. Let me get rid of this so I can move a little bit more freely. Where was I? Okay. So say I want to go from B to A. If I want to get from B to A, this is my direction. It's telling me I need to go down 7 and then over 20. And then I'll have to repeat that. I'll have to go down 7 and then over 20. And now watch. Going down, let me get rid of all this extra stuff so you can see. Down 7. Here we go. 1, 2, 3, 4, 5, 6, 7. And over 20. If you don't mind, I'm going to go by 5s. Watch. 5, 10, 15, 20. And I hit it. They're in intervals of 5s. If you look, makes it a little bit easier to do. The other option would have been to go up from the A and over to the B. So instead of a drop, I will go up and then I'll move left 20. So again, it would have been up 7, would be 1, 2, 3, 4, 5, 6, 7 right here, right? Come on, you can do it. There, and then over 5, 10, 15, 20. And that's how you do it. But this is just the algebra of it all. This is just calculating the slope given 2 points. You don't have to draw it. For example, let's actually just try it out on 2 points. I'm going to give you point A. I don't know. Let's do 3, negative 2. And let me give you point B, negative 6, negative 5. And I want you to find the slope given the 2 points. Well, start off by writing your formula. Formula is M is equal to y2 minus y1. That's also known, guys, as delta y. That's the change in y, the difference in y. And it's over x. That's supposed to be an x2 minus x1. Again, that's known as delta x, or the change in x. We use those symbols, Greek letter for D, for delta. We use the symbol for change or for difference because it's a lot easier than writing this stuff. So sometimes we just use a symbol. The process is the same. Find the difference in the y's, find the difference in the x's. So here's my y's. Negative 2 and a negative 5. So a y2, that would be the back one. That's the second point. So we would have m equal to a negative 5 minus negative 2. And that would be over these guys, the x's. It's the change in the x's. And we start with the back x. That would be the negative 6 minus 3. Take care of your double signs. And you wind up with a negative 5 plus 2. That's a negative 3 over a negative 9. And that simplifies nicely to 1/3. So m is actually equal to 1/3 in this case. I don't know why I put that right there. Okay, m is equal to 1/3. Now, that's the proper way to find slope. And so let me go to something. I'll be right back. Hold, please. I'm back. I gave one of my classes. Which one was it? Shout out if you know. Was it purple? Was it red? Was it blue? Was it pink? I can't remember. Who was giving me the days to look? I think it was my pinks. Pinks, here it is. This is the little quiz I gave you that I thought you knew how to do, and then we realized, not so much, Mrs. C. You didn't teach us this yet. So here it is. Find the slope. Now, doesn't that look easier to do now that you know the formula? So what we want to do is take those two pairs, the -2, 5, and the 6, -8, plug it into the formula. Now you go ahead and do it, and then wait, come on back. I'll wait. You go, I'll wait. You pause, and then as soon as you're done, come back, and then I'll show you how it's done, or you'll show me how it's done. Let's do it. Okay, now here we go. Hopefully you've already done the problem. I'll change to a nice green, and I'm going to say the slope is going to be equal to the y2, that's this one, -8, minus the y1, that's the 5, over the x2, which is that back one, 6, minus the front one, that's minus a -2. Take care of your double signs. There's double signs, make it a positive, and we would wind up with an m equal to a -12 over 6 plus 2, which is 8. Now, that's good, but it can be simplified, right? 2, we can go by 4. 4 into that twice, 4 into that 3 times. That gives me a slope equal to a -3/2. That is what you should have. That is what you should have gotten for that slope. And I just hit the wrong button, so I'm not sure. Hopefully you're still with me because it paused. Okay, so final answer, slope, down here, -3/2. Now, you're going to see the rest of this little quiz we took in class, or it was a pretend quiz, it wasn't a real one. Had some other stuff there. I'm only going over finding the slope, so just saying. Now, I want to take you to a really cool shot of the CUDA website, or you can actually do that right now. Go to CUDA and check out their practice. I'm going to post it up here to save you the time and energy of doing it yourself. And voila, here is 9 through 14, about as much as barely could get that on the screen. This is on the CUDA software website with the free worksheets. It's under linear equations, graphing, or finding the slope given 2 points. And you'll see this is problems 9 through 14, so you can look at the answer keys, or we can go over them in class. I would like to do just one of them. I'm going to pick the one with the easiest numbers. I'm going to do number 14. Yes, I am. So if I come down here to do number 14, I'm actually going to do number 14 above because I don't have enough room to do it below. And so I'm going to plug in these 2 points the way that they're given. And trust me, the directions did say to find the slope given the 2 points. And so now I'm just going to plug it in. So if you remember, it's m is equal to the back y, 5, minus the front y, 2, over the back x, -7, minus the front x, 12. And all we have to do is just put those together and not screw up. So we have the 5 minus 2 is 3. And -7 minus 12, 7, 8, 9, that's a 19, -19. Well, I'm getting the slope is equal to a -3/19. Ew. So what I always do when I get a problem like that, looking like that, I double check my work. So I have 5 minus 2, I agree. -7 minus 12, I still agree. Negative, keep the sign, add 19, 5 minus 3, 9. Okay, I'm happy with it. It's a -3/19. That means my line is going down, right? If you think of it, here it is. Your line is going down, and we don't know where it hits the x, the y, excuse me. So I don't know if it's going down in this direction or going down way down here. Don't know. But I do know that it has a rise of 3 and a run of 19. So actually, I'll make it a little bit less steep because I'm going to go up maybe from any point. Doesn't matter. Up 3, and then I'm going to run 19. Up 3, run 19. So There you have it. Now, guys, I would recommend you practice this a little bit and then check the CUDA website so that you can make sure that you are correct. I didn't take a screenshot of the answers, but it's online for you to do. I hope this helps you out. There's other ways of finding slope, but I think using the formula, the ones they're going to use in high school with you, it's always a good thing to familiarize with yourself. If you start getting confused or getting it wrong because of the backwardsness of it, going to the back and then up to the front, I can show you some tricks when you get in class. So practice, and then, I'll see you on the flip side.